Hello, thanks for joining us today in this informative session. My name is Nicola Kromer. I'm the VP of Product Marketing here at iDirect, and I'm going to be the host for your session today. I'm joined by Savyon, the Director of Vertical Markets, and Chris Boyd, the Senior Director of Vertical Markets and Strategic Initiatives. And today we're going to be talking about Cellular Backhaul and the 5G integration efforts that iDirect is doing. So with that, I'm going to pass it on to Savyon.
Hello, everyone. My name is Savyon, and I'm the iDirect Cellular Backhaul Market Lead at iDirect's PLM. And I'm going to talk today about the trends in the cellular backhaul market and how iDirect can enable you as a partner to extend your offering with cellular backhaul. And then this will be followed by Chris Boyd talking about our initiatives in the 5G area where the cell backhaul flows into. So let's take a look first at iDirect's current market position in cellular backhaul and telcos. iDirect has been a leader in satellite communications for over a decade now, enabling our partners to optimize their networks, provide differentiated services, and expand their businesses and networks into new opportunities. We've been some of the first that expanded satellite into TDMA-based cellular networks, and we currently have 55 cellular backhaul networks deployed around the globe, with the largest one with 1,500 cellular backhaul sites. And as you can see below, we are very well entrenched within 12 of the top telcos around the globe. Some of them operate some of the largest iDirect networks with thousands of remotes. If we're looking at drivers and trends in the cellular backhaul network from cellular backhaul from a global perspective, there's still about 50% of the world population that is not connected to the internet, mostly in rural areas. What happens there is that MNOs are quite hesitant to extend their terrestrial fiber and wireless infrastructure due to cost reaching remote areas, which presents a great opportunity for satellite to reach out to these areas, leveraging the global reach that satellite has. Another big factor is the tremendous success of LTE networks, extending 4G into many areas of the world, mostly in highly populated areas. The 4G is going to continue to dominate the cellular backhaul mobility access. And as you can see, we are expecting a tremendous growth of high-value sites. With that comes the demand for a very high throughput per site in excess of hundreds of megabits per second. You need to also keep in mind that with these high throughputs, there are still entry-level opportunities out there that require much smaller throughputs than that, but will demand the growth to these kind of capacities as the networks are being expanded. And this also is being complemented by larger USO-sponsored projects that mandate the expansion of connectivity to rural areas by governments. All these together present a tremendous opportunity for satellite to grow into the cell backhaul. If we look at some of the applications where satellite can play very nicely into cell backhaul, it's obviously the extension of cellular into rural areas. It will also play a big role in disaster recovery in both aspects of supporting disaster recovery teams going into areas and coordinating and managing relief efforts, and with quick and rapid deployments of alternate communications to any damaged 3G or 4G infrastructure. And finally, the inherent ability of satellite to support multicast can augment very nicely any existing LTE infrastructure in providing video distribution and multicast overlay, for example, for special event services where you have a high density of population. So let's look into more details on the technology implications and how iDirect addresses them one by one. So when we look at the increasing traffic volumes, this has a double effect of influencing the OpEx of the network. You want to obviously use the minimum bandwidth as possible to save as much of the network as you can. And you also, which brings us to the second element of intelligent optimization. The platform that you're using has to be able to optimize any combination of voice, video, and data, accelerate and compression in order to save the maximum amount possible of capacity, again, to save on OpEx as well. All this has to happen, of course, without affecting the end user experience, so we can get exactly what he expects and what the service level agreement with his operator allows him to have. And obviously, as networks are moving more and more into being a hybrid combination of mixed media, you have to be able to integrate your satellite network into the mainstream telco networks. And you need to adhere to the different standards that telcos are using today. And finally, going back to the terminal itself, you obviously want to be able to support all the different generations and be able to scale the throughput availability all the way from very slow capacities of a few megabits per second to way beyond 100 megabits per second per the terminal itself. So let's take a look at these implications one by one and see how iDirect addresses them. Overall, the iDirect platform is inherently built to support top-grade solutions for cellular network, and this is a combination of several elements in the system which combine together a very good system to address these needs. And it goes all the way from the scalable hub architecture that can support universal line cards that can grow with the network and also maintain a very effective TCO, to the remote terminals that can support a multitude of cellular backhaul cases from 2G to 3G for small cell to high throughput 4G all the way to Wi-Fi, and also combine all of these together. This is complemented by the underlying traffic engineering features of the iDirect system, combining world-class quality of service, layer 2 for easy integration with terrestrial network, bandwidth efficiencies with security and API that enable tying all this back into OSS and DSS system. On top of that, iDirect is also offering the Satellite XE application to even further enhance and accelerate the user experience for cellular backhaul specific traffic. So talking about efficiency, in order to optimize OpEx, the iDirect system supports the best bandwidth efficiencies today with up to 30% gain with DVB S2X, goes all the way to 256 APSK, and with the fastest available adaptive TDMA return channels up to 15 megabit symbols per second, with 16 QAM that enable today a throughput of about 40 megabits per second on the return channel, which enables our partners to leverage any capacity that they have on any band more intelligently. With the Backhaul XE application that I mentioned earlier comes the additional ability to optimize cellular backhaul specific network, which means getting into the actual cellular tunnel layer and accelerate it without affecting the user experience. So this allows, for example, getting into the GTP tunnel in LTE networks and accelerate and compress the networks using compression, packet coalescing, and also the ability to maintain the security over this network without affecting the user experience. This, depending on the traffic mix, this can result in throughput savings of up to 30%. The advanced QoS engine built into the iDirect system enables a multitude of service level options in various ways. It enables stitching any type of capacity together to combine any type of tiered support for multiple customers, and at the end user level, enabled to handle multiple applications of voice, video, multimedia, file transfers, without all of them living together and getting to the end user as expected to be delivered. And also, there is the ability to deliver streaming services over the top using the multicast available for offloading traffic and network content delivery. Talking about integration into mainstream networks, iDirect is in a constant effort into looking into integration into the Evolve packet core, which we're going to talk a little bit more in details later on. iDirect also has the most complete layer 2 over cell-like implementation that can extend into a hybrid terrestrial infrastructure. iDirect also is starting to implement network function virtualization into its offering to play with software-defined networks, and obviously we are extending our API support on both ends of the networks to enable seamless integration to OSS and BSS, evaluating technologies and APIs such as NetConf and YAG. On the terminal side, iDirect has recently came up with a high-advanced remote portfolio based on a scalable software-defined architecture, which enables, obviously, to support and take advantage of all the advanced efficiencies. Again, easily being integratable with APIs into either a web or any other underlying APIs. The software-defined architecture enables you to future-proof your terminal by enabling new capabilities to be driven via software rather than going back to the site and replacing the terminal itself. All this is being complemented by a very quick and easy installation and commissioning of the remote itself. So here is a quick overview of iDirect remotes, all the way from the legacy X series to the newer IQ series. The X series with the X1 and the X7 family is the current market leader on the low and the medium enterprise level together with cell backhaul. And as you can see, for the X1, we have two form factors of either outdoor or indoor to support various applications together with cellular backhaul, leveraging all the features that I had discussed previously. For higher-end enterprise that requires additional mobility support, you can utilize the X7 family, which also includes the X7 EC that is embedded with the Backhaul XE application for further optimization of cellular network. And with the new IQ series, we are now supporting either DVB-S2 or DVB-S2X to enable migration from DVB-S2 networks or into the higher efficiencies of the DVB-S2X. So we're starting with the IQ desktop, which is again a high performance, low entry-level, low enterprise remote to support cellular backhaul application, and the IQ200 series that can support enterprise cell backhaul application with either rack unit form factor or to be embedded with, for example, a BTS with an integratable card. And the latest in this family is the IQ LTE, which combines both the IQ200 and an LTE router inside one box for a single solution for a high availability and disaster recovery of both wireless and satellite solutions. Let's talk a little bit about the Backhaul XE portfolio for the terminal. So as I mentioned before, the Backhaul XE is a special application that enhances further the savings for cellular backhaul of all types, 2G, 3G, or 4G, and also enhances the user experience. The Backhaul XE is offered as an embedded application on the X7 EC router. So with one box, you are getting an all-in solution that can support up to 70 megabits per second of throughput for entry-level 3G or 4G cellular backhaul network. For a higher capacity that require excess of 100 megabits per second, you can combine a Backhaul XE appliance together with an IQ200 for a complete bundle that can support up to 200 megabits per second with 8 gigabit ports on the backplane of the appliance. This appliance can be also paired with any iDirect modem for various types of solution with either the 9350 or the X7 or even the IQ desktop. On the hub side, we are offering 3 flavors of the Backhaul XE application to either complement existing hub infrastructure that our partners are using today or to support a more advanced cloud infrastructure for customers that are already deploying cloud compute. So we are offering the Backhaul XE either as part of, as extension of Universal Hub on the Dell R640 server, or as a sled as part of the iGateway chassis. And as you can see, there is a big difference between the performance that is available on these platforms, either up to 400 megabits per second on the Universal Hub server or up to 1 gigabits on an iGateway sled. And the last solution is a software license that can be virtualized on any type of private cloud infrastructure, and it can take you up to 1.3 gigabits per second support with a very high support for large cellular backhaul networks for up to 200,000 sessions. All the features of the Backhaul XE are all-inclusive in the single license, which means that you are getting the support for the packet coalescing, the header compression, the packet compression, and the support for IPsec all in one license. Going back to the cellular use cases that I already mentioned earlier, let's go a little bit in more details on these use cases, from extending cellular backhaul access to rural areas, to disaster response, to Wi-Fi offloading of both multicast and network congestion. The first use case is already very well understood and in the market. It's basically leveraging the reach of the satellite where terrestrial infrastructure cannot get into. So this lends itself to basically very large regions that either have only 2G or 3G access today, but they are also getting ready to deploy 4G. So with the iDirect solution together with Backhaul XE, you can support migration scenarios from existing voice-only 2G networks all the way to 4G, all in one solution, deploying it once and never worrying about going back into the site. For disaster recovery and first response teams, as I said earlier, the iDirect solution lends itself very well in supporting a complementary or disaster recovery service for connectivity for both response teams, as they are getting, from the minute they are getting the call to get to the site, supporting them en routing if necessary over a mobile platform once the LTE or the other wireless connection fails, and then supporting on-site relief efforts, enabling the response teams to communicate via satellite with other agencies on the ground and with the governments to support the relief efforts. The third use case is also a very well understood use case for MNOs and telcos that have to deal with high density areas such as stadiums, arenas, and airports, where there's a high demand for connectivity and very low cellular capacity. This led to a growth of Wi-Fi standards such as Hotspot 2.0, which basically enable a single sign-on for users to switch between either Wi-Fi or cellular without the user intervention and going back to the same mobile core while all the authentication and the switching happening in the background. So users can switch between the two depending on the demand automatically. This type of connectivity can absolutely be supported over satellite as well in remote areas. You can have both your Wi-Fi access point and your NOD, for example, connected to an iDirect terminal together with the traffic separated on two different ports and VLANs, for example, and let the system handle the automatic switching between the Wi-Fi and the mobile network automatically. This has the added benefit of providing an option for the SSP network to go directly to a local internet breakout, thus saving the need to go back to the MNO core network through the EPC. So this is an overview of the market trends and how iDirect can support our partners in extending into the cell backhaul network. iDirect offers a complete solution that can scale up or down depending on the demands and support all the generations of cellular backhaul. In addition to the sheer opportunity of the cellular backhaul, it also plays a big role into extending into the 5G trend. And with the iDirect solution, you can firstly be assured that the solution that you deploy with iDirect today is forward compatible with 5G. Once you deploy the iDirect terminals and network in place, they will work with the future 5G cell backhaul. However, the 5G story is much bigger than that, and iDirect is already making serious strides in leading the market in this direction. With that, I'm going to pass the presentation to Chris Boyd, who is going to talk about 5G in more details.
Hi, my name is Chris Boyd, and today I'm going to speak to you about the efforts that iDirect has been underway to innovate our platform to support satellite 5G integration, and to talk about some of our public proof point demonstrations through our work through the European Space Agency and our partner consortiums. So for iDirect, what is the importance of 5G to the satellite industry, and how do we view the 5G industry evolving to include satellite? Clearly today, we view that satellite and terrestrial wireless are on a collision course. We say this for many reasons. One is, if you look at the landscape of investors that are investing in both 5G and currently invested in satellite, we have some of the same players emerging. For example, SoftBank has made a large investment in a number of different satellite orbit constellation players, as well as has equity placements in a number of terrestrial wireless companies like Sprint. We also see, as a part of the 5G area, there is common overlap between frequency band requirements. It's been well publicized that there is some significant overlap in the 5G millimeter wave requirements for the 5G NR waveform. And those same requirements overlap with the C-band spectrum in the VSAT market. We also see that terrestrial wireless and VSAT have common markets. Many of our remote locations that use VSAT today are being extended in the terrestrial networks to be covered by LTE space. So we see that these collision course is inevitable, and that we think that an investment in our platform to bring the VSAT capability of the satellite and VSAT space to the terrestrial 5G actually make a complementary offering for our customers. We also believe that 5G is more than just about the 5G message that you hear from the cellular carriers about being the next gen of 4G. We actually think that 5G plays a more crucial role in the concepts surrounding the actual technology. In two areas, one is the concept of the unified RAN. In 5G, a lot of the concepts today around the cellular radio air network are extended to include software-defined components. We also believe that some of the technologies around network slicing and those requirements lay very well with our current implementation of virtual operator or VNO type capabilities. So we believe 5G is more than just about innovation in the waveforms, but also to include innovations in the actual technology in terms of software-defined networking, network function virtualization, and our ability to take advantage of innovations that have happened in those areas in terms of scalability and using cloud scale technologies to increase the capability and scalability of the 5G networks. So we believe that satellite industry must participate in the 5G standardization process, and this is a critical factor for the satellite industry. Today, we're focused on integration with the established 3GPP and orchestration framework standards. We believe that as we adopt those standards, this will become for our customers more cost-effective and easier to deploy in these terminals, because I don't have to maintain the satellite network as a separate and bespoke network, but rather integrate these things into the larger OSS and BSS framework. And we also believe that 5G and its view of the use cases are quite complementary. And I'm going to talk a little bit more in detail about this in the next slide. So if you look at the 5G landscape today and what is being focused on through the standardization efforts of 5G, the standards actually call out 3 specific use cases for the terrestrial 5G initiative. Those 3 are listed on the right, first being the enhanced mobile broadband use case, and this is really about driving the next-gen capability that we all hear about through the marketing campaigns of the cellular carriers about faster speeds to our handsets and opening up fixed wireless connectivities to replace last-mile copper or fiber connections to our homes and businesses. The next use case is really about massive machine type connections and how do we drive scale to support things, to connectivity options for the Internet of Things, whether this be sensors and surveillance opportunity, as well as things like ATMs. So this massive amount of sensor connectivity for all of the things that we want to connect is driving a whole area of innovation in this massive machine type communications. The last use case is really around something called ultra-reliable low latency communications, which is a very large focus of the next-gen capability within the cellular networks. Principally, this is geared towards edge compute and edge connectivity of devices that have high speed and high low latency requirements, such as vehicle to everything or V2X capability. In this example, we would have cars communicating with each other while platooning down a smart highway or interacting with the infrastructure around them to understand traffic conditions and reroute automatically. This is incredibly important as we move towards autonomous vehicle applications and expanding those into more of a broad use. This use case also covers automation equipment for construction, mining, and other conditions where feedback and telematics information from these devices is critical. One of the things that's interesting about the ultra-reliable low latency communications is many times the terrestrial players will discount satellite's ability to play in this space. And we actually argue that we're very good at half of that equation. We're very good at ultra-reliable, not so good at low latency. Obviously, the changes in different satellite orbits are improving the latency conditions, but satellite is always an order of magnitude larger latency. But if we focus on how iDirect can participate in 5G and how 5G can address this third use case, we believe that there's still value for satellite to play in providing capability and connectivity to these devices under the ultra-reliable low latency communications use case. And principally, that's around software and firmware over-the-air updates and multicast distribution of infotainment to these sites. So if you can imagine, with multicast capability on the satellite, we can address millions of terminals all at one time. And when we envision that we might not be driving our cars in the future, we're going to be consuming content as we travel. Satellite's value has been long established in our ability to move massive amounts of content over multicast networks to millions of places at once. So our satellite value really, if we look at our design here, we actually show that the satellite RAN, or the satellite radio area network, can be mirrored and emulated to act just like the terrestrial 5G RAN, where we emulate our system to look just like a G-Node B in the terrestrial system. At this point, an operator or a mobile network operator shown here using a 5G core would be able to configure and deploy services into any of the reflected use cases, whether that be terrestrial-based or satellite-based, with a common framework, common orchestration, and common standards, so that the satellite network does not look different from the terrestrial network. This allows us to start to enable use cases where we have hybrid connectivity between 5G terrestrial and satellite, and connected vehicles is a good example of that, as I mentioned. iDirect has been very forthcoming in collaborating with technology partners to push forward these concepts. We believe that an embrace of the satellite industry towards 5G standards is critical to bringing satellite to the table as a part of these 5G use cases. So iDirect has been participating directly in the 3GPP standards initiatives around 5G and satellites play within the 5G ecosystem, as well as other organizations like 5G PPP and ETSI, who are driving a number of other framework standards supporting 5G deployments. In addition to the standards organizations, iDirect has also been participating in a number of the industry initiatives around orchestration through the Metro Ethernet Forum, through standardization efforts of IETF, through other industry initiatives in the Linux Foundation and ONAP. In addition to this, we participate as a part of the participant in the EMEA Satellite Operators Association, or ASOA, which is actually quite an honor for iDirect as a vendor to participate in a consortium of satellite operators. The ASOA is really focused on driving a number of the satellite-based interest in 5G into these other standard bodies as well. In addition to these industry standards and industry initiatives work, iDirect has also been participating in a number of 5G consortium and other grant-based projects through the European Space Agency and the European Commission. I'm going to go into more detail on these projects in a few slides. As I mentioned, these demonstration projects are joint 5G technology innovation testbeds, and we've been participating namely in 3 key projects. The first of which is called SAT5G. This is a European Commission project under the Horizon 2020 5G PPP project, and was a completely funded project at which drove a consortium to research, develop, and validate key technology enablers for iDirect to demonstrate plug-and-play integration of satellite into the 5G network, with focus particularly on the first of the 3 use cases I mentioned, which was enhanced mobile broadband. The second project which we participated in was a consortium demonstrator for satellite terrestrial integration of the 5G context, extending those use cases from not only the enhanced mobile broadband case, but to also start to identify how to solve massive machine type connectivity along with terrestrial convergence in the 5G context. And the third project is EdgeSat, which focuses on an innovative component of 5G, which is the increase of edge compute requirements to address some of the ultra-reliable low latency communication requirements, and also the ability to support more enhanced communications and compute at the edge of the network. So EdgeSat's focused on driving applications, implementation, and validation of edge networking concepts deployed in satellite networks. So iDirect believes we have a number of technology innovation steps. One is we're invested in developing and deploying a multi-orbit SDR waveform platform. We believe that 5G doesn't stop with just terrestrial waveform innovation like 5G NR, but also involves a multi-orbit strategy to bring 5G capability to GEO, MEO, and LEO satellite constellations. We believe that in order to drive some of this technology innovation, we must embrace standards and open source and utilize those standards in our platform along with open source capability to extend our platform to drive the next level of scalability and performance. Namely, cloud scale is really where we're focused to drive our platform using cloud native technologies from hundreds of thousands of terminals towards another level of performance at 1 million or more terminals in a network. So iDirect is focused on next-gen innovations, and to do that, we must adapt that satellite platform architecture to support these capabilities. As I mentioned, one of the key initiatives at iDirect is to extend our system to support multi-waveform and multi-access. Multi-orbit service definitions require the platform to handle multiple path links over MEO, GEO, and terrestrial. The 5G model and some of our research shows that many of our customers have already started to think through service use cases which require multiple orbit or multiple connectivity links. Using the power of software-defined networks and software-defined wide area networking, we are creating ways for our customers to create end-to-end service orchestration where particular traffic may connect over multiple orbit or multiple links. In addition to this, we're innovating in the area of scalable new area networks, which are software-defined, which allow our next-generation modems to take advantage of whichever waveform is required for the link, and to have that platform be seamless to the core of the network, allowing, as I mentioned in the previous slides, our satellite network to be a part of the unified RAN concept, allowing customers to very easily deploy whether that service be terrestrial-based service, a satellite-based service, or a hybrid variation of both. Part of our initiative is to implement standards-based management frameworks. As I mentioned, as we try to scale the network up, we realize that we now need to invest in standards-based frameworks which allow us to take advantage of some of the cloud scale technologies that are available today in the open source space. So we're focused on a next generation management platform which creates a scalable network for element management of our customers' terminals and allows them to view and monitor and manage those terminals in a seamless and consistent way. And whether that's managing it through our NMS platform or whether that's to integrate it with higher order OSS and BSS systems, we believe that we must create a standards-based framework to do that. One of the ways we're doing that is adoption of open standard from the existing telco technologies such as NetCompany for terminal creation and element management by extending our platform to support virtualization and private public cloud implementations, to use cloud-native SDN and NFV standards such as lifecycle orchestration management, as well as extend our system to support more deeply integrated systems with OSS and BSS with our customers' platforms. Further, as we deploy these technologies, we need deep data analysis of trends and correlations to allow our customers to quickly manage, troubleshoot, and offer scalable SLAs for their customers as we move towards service enablement. So through our research and projects that I've mentioned, we believe that iDirect is contributing to driving ecosystem innovation. There are 4 key areas at the bottom that I've mentioned as part of the standards efforts within 5G. Obviously, we're very aware that 3GPP is very ingrained in what is happening with the standards around 5G. But as I mentioned, 5G isn't just about the waveform and the radio side. It's really about the software-defined networking and the expansion and scalability of the ground system. And so other components that we're focused on is the virtualization layer and the orchestration layer, and we're focused on doing that through the ETSI-MANO framework. So each of the projects that we have listed, Sat5G, Status5, and EdgeSat, they are all focused on driving multiple aspects of 3GPP integration, the virtualization and orchestration layer, as well as now MEO, which is medium Earth orbit satellite constellations, and integrating those today with existing GEO orbit satellites, as well as terrestrial LTE. And then finally, the EdgeSat project drives towards the concepts of multi-access edge computing, which is also a key component of the 5G initiative. And we're doing that through both the EdgeSat project and a project called Osmosis, which is about driving content over the top through multicast. So let's take a look at how we're taking these technologies and concepts and applying them to real-world applications. iDirect has, as I mentioned, been involved in a number of publicly funded programs through ESA and the European Commission to demonstrate key benefits of satellite backhaul and 5G integration into standard 3GPP core network architectures. These 3 demonstrations, starting about a year ago, at the European Conference on Networks and Communications, or EUCNC, was the first of its kind public demonstration of an integration of satellite into the 5G core network. We followed that up with a demonstration at the FUSECO Forum, which demonstrated a further expansion of 5G and satellite integration using the slicing concepts within 5G, as well as mapping those slicing concepts to the vertical use cases I described. And finally, we highlighted and culminated the work of both of these other projects into a public demonstration at the Mobile World Congress 2019 in Barcelona, which was a culmination of not only the first two projects, but also brought in technologies from our Osmosis project. I'm going to go into a few more details on these projects in the next slide. So as I mentioned, the first proof point that iDirect participated in was the EU CNC project, which was just about 1 year ago in June of 2018. This was the first of its kind over-the-air live demonstration towards satellite integration of 5G. This was a consortium project driven through the European Commission called SAT5G and had a number of partners from the University of Surrey, Broad Peak, SES, iDirect, I2CAT, and others, which came together to drive the initial concepts of 5G and standard integration of 3GPP into a architecture. This highlighted the use of SDN and NFV integration at the core layer, as well as efficient edge content delivery over satellite. It also highlighted some work in multi-access edge computing. This use case really focused on driving video content distribution over a core network and providing real-time transcoding of adaptive bitrate video to endpoints, in this case, mobile endpoints, on the remote side of the network using live HLS dash technologies to provide video content in real time. The second proof point, again, was layering up the technology innovations. This was actually a part of a SAT-IS5 consortium funded under the ESA. This project expanded the work that we did to integrate standard 3GPP network architectures into a few other areas, namely to expand the demonstration of network slicing of multiple use cases for enhanced mobile broadband and massive machine type communications for those use cases I described earlier in the satellite environment. And then finally, it expanded the multi-access edge computing node to actually include edge radio access for mobile devices. So in this case, we partnered with SES and Fraunhofer Focus, which is a part of the German Fraunhofer Institute, and our partners there to essentially demonstrate the two slicing concepts of mobile, enhanced mobile broadband and massive IoT slices over a public 5G core using the open 5G core developed by Fraunhofer over an actual satellite network distributed to an edge compute node, which then provided broadband communications, IoT communications, and a demonstration of ultra-reliable low latency communications between nodes at the edge. And finally, the culmination of these projects all together were demonstrated at Mobile World Congress 2019. And this showed a satellite integration into the latest 3GPP Release 15 compliant 5G core network. Again, using a variant of the 5G core called Open 5G core developed by Fraunhofer. We integrated that into the satellite RAN and then further inter-networked that Open 5G EPC into a second Osmosis EPC showing interworking between two carriers to deliver content distribution from the core of the network to the edge. This also highlighted the enhanced mobile broadband use case, which allowed connectivity to devices at the edge of the network. One additional use case on top of this was the inclusion of the Osmosis technology, which demonstrated adaptive bitrate video streaming and content network integration to the edge of the network. In this case, we showed real-time video distribution over multicast into the edge of the network where that video was cached and transcoded in real time to the devices. In this demonstration, we had a local radio device which was providing a local RAN integrated into the mobile edge compute node. This allowed local communications between the handsets as well as accessing of cached information on the mobile edge compute platform. So in this example, we were able to distribute live video transcoded to handsets, HDTVs, and PCs all at one time, as well as access to stored and cached video on demand content at the edge of the network. By having this information pre-populated at the edge of the network, it alleviated the amount of congestion on the link and was smartly redirected by the handsets to the local cache based on requests to the network. These concepts all layer together to show a very forward technology approach to our investment in the 5G and our partnership with our consortium partners and ESA. So to summarize, we believe 5G is our attempt to reach brand new markets. iDirect provides a complete offering of service providers to service providers to help mobile network operators extend their backhaul, whether it be traditional 2G, 3G, and 4G cellular backhaul, whether it be an expansion of that technology into 5G. We believe there's a lot of opportunity for mobile network operators to utilize satellite today in backhauling operations, as well as in the future to be more integrated into their operations. iDirect is focused on delivering best-in-class performance, efficiency, and user experience while offering seamless integration with our MNO infrastructure and operations. We believe this is key to bringing VSAT into the forefront of capability with our partners. And as we've spoken about, we are actively ready, getting our customers ready for migration from 2G, 3G to 4G, and from 4G LTE networks into 5G networks. With that, I thank you for your time. And,
thank you, Chris. Thank you, Savyon. We are now at the end of our webinar. We would like to thank you for joining us today, and if you have any questions, you can contact us at marketing@idirect.net. Thank you.